Right, today I'm going to be looking at the graph of a hyperbola. Couple of points that really need to be looked at here is you have got a vertical asymptote on the x-axis and a horizontal asymptote along on the x-axis and a vertical asymptote along the y-axis. As you can see, you've got two parts to this graph. You've got the top right hand quadrant curving down, and we have got the bottom quadrant here curving to the left. Now this here is a function in the form of, just get my pen to work, function in the form of y equals a over x. This function here hasn't moved anywhere to the left or right. This is just a standard hyperbola. Right, so all we need to do really is we need to find out what this value here a is. So all we do is we look from the intersection of the two asymptotes and we go, how much do we go across and how much do we go up? Because another way of writing this here is actually xy equals a. So you can actually find out what the a is just by multiplying the x coordinate with the y coordinate. So in this here, where our x coordinate is 3 and our y coordinate is 2, so it's just 3 times 2, so that then gives 6. Let's check another coordinate here. We go across 1 and up 6. This coordinate here is just 1 times 6, which is 6. So see, it doesn't matter which point you take, you will always get the same number. So this equation here is then y equals 6 over x. Okay, now if we actually look at another function, if I take another function, if I go something like y equals 4 over, I don't know, x minus 2, and then I'll go plus 1. Let's see what's happened. Okay, a couple of things that we're going to look at here, and I'll just get my pen back. And what we can see is we can see that we've got an asymptote sitting along here, and this asymptote is sitting along at 1, 2. It is sitting across at the point x equals 2. And another asymptote, which they don't actually draw in, but as you can see, it gets closer and closer and closer to this line here, which is y equals 1. It gets closer and closer to y equals 1. So therefore what we've actually got is we've actually got y equals some number which we don't know on the top over x. We've actually moved to the right 2, so then this here is then going to be x minus 2, and we've actually moved up 1 because our asymptote is now up here, has moved up 1 unit. So we've actually got an asymptote along this line here. Now what we want to do is we want to find this number up the top. Now to find out this number up the top, we want to go from the intersection of our two asymptotes, we go across, and then we go up until we've actually got a point. Okay, this time we've gone across 1, and again remember it's from our asymptote, so we're actually up 1, so we've gone across 1, and then from here we've actually gone up there 4, which means 4 times 1 happens to be 4, so that there is your a value. Okay, that's how the graph can move left and right and up and down. What about another graph? We will have a look at one, maybe if that is a 3, and make this a plus 1, and make this then a minus 2. If I can get it to go back up to there, minus 2. Right, let's have a look. Again, we've got at this one here, we can see that our asymptote, if we actually get our pen back, we can see our asymptote 1, 2 is along here. So we've actually got an asymptote that's sitting along this line here, because that's the line that it's getting closer and closer and closer to. This particular function, this particular graphing package doesn't actually show the horizontal asymptote, it just shows the vertical one. Right, so again what we've got here is we've got some function which is y equals something over x, and then what we've done is we've actually moved the asymptote, we've actually moved it down 1, 2, because that's where the two asymptotes intersect, so we've moved it down 2, Now then, what have we actually done? Whether we've moved it left or right, we've actually moved it across here. We've gone across here, 1. So if we've gone across 1, that must be a plus 1 there. Now all we've got to do is just go from here. We've actually got to get a point. Now we can actually get one of these points here. That one there looks as if it crosses a point very simply. So if I go across 1 and I go down 1, 2, 3. So 3 times 1 is 3. So the number up the top is 3. Okay, I've got to try it over the other side. Across 1 and up 1, 2, 3. Right, I could also go across 3 and see what would happen there. If I went across 1, 2, 3, I actually go up 1. So again, it's just 3 times 1, which is where I get the 3 from. So that's how our hyperbola moves up and down, and that's always how you can get what the number on the top is. Remember, it's the intersection of the two asymptotes. That point there is wherever is your key point. That there tells you how the whole graph's been translated, moved down or up, and it's always from that point there is going to tell you when you go across and up what the A value is up the top. Okay.